So yesterday we built off of rates and unit rates, and we talked about how relationships can either be proportional or non-proportional. Remember, if they're proportional, that means that they have a constant ratio or unit rate. Remember, we said constant means that they have rates that simplify to the same unit rate every time. We also talked about non-proportional relationships, and non-proportional relationships means that they do not have a constant rate. We also did 2 examples yesterday on the back of this paper. The first one was about an elephant, and we said that an elephant can drink 225 liters of water each day. Okay? Since they drink that each day, we made a unit rate of 1 over 225. We then used that unit rate to create the other rates, meaning we went 225 times 2 to give us the 450, 225 times 3 to give us the 675, and 225 times 4 to give us the 900. Since we used the unit rate to help us build the rates, it was proportional. Then we talked about the marina. Okay, and we said that the marina was non-proportional because we knew that you would pay $25 per hour, but then you also had to do the plus 12. That plus 12 is what threw it off for not being proportional, because when you took the 2 rates that we created using this equation, they did not simplify down to the same unit rate. Today we're going to talk about how you can use multiple representation to show if relationships are proportional or non-proportional. It says the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes. So my key word is per. That word per tells me that I'm going to multiply. We're also going to talk about the terms independent and dependent. Okay, so the number of feet is dependent on the number of minutes that the tree sloth moves. So my distance, I'm going to come down here and I'm going to put that is dependent, because it depends on the number of minutes. So my time is the independent. Okay, so in my equation, I'm going to let time be x, because I don't know how many minutes this sloth is actually going to be moving. But I do know that for every 1 minute that he moves 6 feet. So my equation would be 6x. Okay, so 6 would be the number of feet. Okay, and the x would be the number of minutes that the sloth is moving. Okay, so now if you look at our chart, we have 1, 2, 3, and 4 minutes to figure out. So you would do 6 times 1, which gives you 6. Then you would have 6 times 2. You would have 6 times 3. And you would have 6 times 4. So I'm going to come through and I'm going to fill that out in my chart. So in 1 minute, he goes 6 feet. In 2 minutes, he goes 12 feet. In 3 minutes, he goes 18 feet. In 4 minutes, he goes 24 feet. So now I'm going to go back into the table and circle, like yesterday, right here. Okay, and I'm going to label this my unit rate. It's my unit rate because I have in 1 minute, I know how far he goes. And then that makes 2, 3, and 4 my rates. Now, if you go back to the table, I don't have this part filled out. Okay, I want you to think about it. If the sloth doesn't move, okay, 0 minutes of moving, he's not going to go anywhere. So that would be a 0, 0. Okay, and now I also want you to circle this, and this is called the origin. Okay, it's the starting point. So write in origin. Okay, so we're going to start this unit, and we're definitely going to use it next unit. So far we have a verbal representation, we have an algebraic representation, we've done our table. The next thing we're going to do is we're going to create our graph. So our time is our x, our distance is our y. Okay, so now in your graph you have a vertical and you have a horizontal. The horizontal is your x values and your y is your vertical values. So if you look, x represents time, so I'm going to label time down here. My y represents my distance, so I'm going to label distance right here. And then I'm going to put a 0. And I'm going to go and I'm going to look, and my x's are counting by ones. So I'm going to count by ones down here at the bottom, but I'm going to skip spaces so that my graph is pretty. Okay, and then now I'm going to go to my distances, and they're counting by sixes, so I'm going to go ahead and do that as well. Okay, so now I'm going to go through and I'm going to plot my points. So I'm going to make a list of my points as well. I have my x's first, then I have my y's. My first x is a 0. My first y is a 0. Then I have a 1, 6. I have a 2, 12. And I have a 3, 18. And a 4, 24. Okay, so now I'm going to go through. You find your x's first and then your y's. So I'm going to find 0, 0. I'm going to put a dot. Okay, so I did that one. Next one I'm going to find is 1, 6. So I'm going to go to 1 and then go up to 6 and put a dot. The next thing I'm going to do is I'm going to find the 2 and the 12. Okay, I'm going to have the 3 and the 18. Next, I'm going to have the 4 and the 24. Okay, so the next thing I'm going to do after that is I'm going to connect my lines. So now I can look at the graph and we can see that we have a proportional relationship. Now, one of the reasons that we have a proportional relationship is because we were able to take the unit rate and build the other rates. Or we could take the rates and we can simplify them, meaning divide them and get the unit rate. So for example, 12 divided by 2 gives you 6. 18 divided by 3 gives you 6. 24 divided by 4 gives you 6. Now, on a graph, it's really easy to tell that if it's proportional or non-proportional. If you look, our graph starts at 0, 0. Since our graph starts at 0, 0, or starts at the origin, that means that it is a proportional relationship. Okay? So I would write that it's proportional because we were able to build our rates from the unit rate, and our graph starts at the origin, which is the same thing as 0, 0. Okay? So this relationship is proportional because we have a clear unit rate. That unit rate was used to build our rates. You can also check your rates and divide them or simplify them to make sure that you get, for every 1 minute, it goes 6 feet. When you graph your points and connect them, you see that it starts at the origin. Since it starts at the origin, that means that it is proportional. Okay? I hope this video was helpful. Thank you.